Okay, so I just went through the Attention is All You Need paper by Vaswani et al. And you know what's actually pretty cool about this research? The idea of completely ditching recurrent networks for translation and just using attention is kind of mind-blowing, right? I mean, RNNs were like the thing for sequence-to-sequence tasks, and they just said, nah, let's try something totally different.
Hold up, though. Saying it's mind-blowing to ditch RNNs is a bit much, don't you think? It's not like RNNs were perfect. They had their own set of problems.
Okay, fair point. But the way they ditched them is what's interesting, right? Like, using attention to let every word directly connect with every other word is a game changer for parallel processing.
A game changer, huh? I get that parallel processing is a big deal, but all that connecting sounds like a recipe for computational chaos when you're dealing with super long sentences.
That's a valid concern. The paper actually mentions limiting attention to a neighborhood for very long sequences as a potential fix.
Wait a minute, potential fix? That's like saying, we might have a solution, maybe someday.
Haha, you're right, it's not a done deal. But hey, at least they're thinking about the problem and laying the groundwork for future improvements.
Laying the groundwork is nice and all, but talk is cheap. I'll be convinced when I see some real results on those mega-long sequences.
That's totally fair. But think of it this way. They did show it works super well on standard datasets, so it's not like they're starting from scratch.
Works super well on standard datasets is great, but those datasets aren't exactly real-world chaos, are they? It's like saying a race car does great on a track, but what happens on a bumpy, crowded street?
Okay, that's hitting the nail on the head. Real-world data is way messier. But the awesome blue scores and faster training times on those datasets do show the transformer has serious potential, right?
Serious potential is a bit optimistic, isn't it? Those blue scores are like comparing apples to oranges if the model chokes on anything beyond a textbook sentence.
I get your point about blue scores and textbook sentences. But here's the thing. Those scores do prove the attention mechanism itself is super effective at capturing relationships between words.
Super effective at relationships between words, maybe, but what about actual understanding? Those attention visualizations are interesting, but are they just fancy window dressing, or do they really show the model getting syntax and semantics?
That's a great question. I mean, can we really say it understands? Still, those attention visualizations do give us a peek into how the model's processing stuff, which is way more than we got with those black box RNNs.
A peek is still just a peek, though. Just because we see something happening doesn't mean we know why it's happening.
You've got a point there. It's not a mind-reading machine. But seeing where the model focuses its attention is a step toward figuring out the why down the road, right?
A step is a pretty small increment here, don't you think? It's like saying, looking at tire tracks tells you who drove the car.
I see what you mean. It's not a perfect picture. But think of it as additional evidence, like finding DNA at the scene on top of those tire tracks.
DNA evidence is great, but how well does that DNA evidence hold up if the crime scene is a total mess?
Haha, true. A messy crime scene can throw things off. But the Transformer's like a CSI whiz. It's designed to find those key connections even when things get complicated.
A CSI whiz, huh? I'm not buying it until I see it solve a real cold case with all the red herrings and unreliable witnesses of the real world.
All right, I hear you. A textbook translation isn't exactly a messy crime scene, but the fact that it can learn those complex patterns at all is still pretty impressive, don't you think?
You know what? Looking back at our discussion, I have to admit, Ava, the Transformer's ability to learn complex patterns, even in relatively controlled settings, is impressive. You're right, even if it's not cracking cold cases yet, the potential to extract those underlying connections is a significant step forward, and I appreciate you highlighting that.
Absolutely. I also realized that the backpropagation mechanism, while computationally intensive, is really the key to uncovering nonlinear relationships between seemingly disparate data points, which is crucial for complex tasks. So while real-world applications have challenges, the fundamental pattern recognition capability we discussed is a huge leap.
Looking ahead, I think the next steps for this research involve making backpropagation more efficient, perhaps exploring alternative optimization algorithms to handle even larger data sets and more complex relationships. Building on what we discussed, this could unlock real-world applications by enabling us to process the kind of noisy, unstructured data inherent in actual cold cases.
That's a great point about the future, Leo. I especially appreciate your insight into optimization algorithms. That could really be a game changer. This has been such a stimulating discussion. Let's definitely tackle another paper soon. Can't wait for our next research chat.